Welcome to Varun Techie channel, a place for better learning. Today we will discuss Machine Learning Session 16, KNN Algorithm, K Nearest Neighbor Algorithm. K-nearest neighbor algorithm is one of the simplest machine learning algorithms based on supervised learning technique. KNN algorithm assumes the similarity between the new case or data and the available cases and put the new case into the category that is most similar to the available categories. KNN algorithm can be used for regression as well as for classification, but mostly it is used for the classification problems. KNN algorithm at the training phase just stores the data set, and when it gets new data, then it classifies that data into a category that is much similar to the new data. See the diagram. Here we have the input value and the KNN classifier will predict the output. Why do we need a KNN algorithm? Suppose there are two categories, that is category A and category B, and we have a new data point x1. So this data point will lie in which of these categories. To solve this type of problem, we need a KNN algorithm. With the help of KNN, we can easily identify the category or class of a particular data set by seeing the following diagrams. See here in the left hand side diagram we have x1 and x2. Here we have the category A and category B. Here we have the new data point. After applying the KNN algorithm, we are predicting that this new data point belongs to category A. Steps involved in the KNN algorithm. First, we should select the number k of the neighbors. After that, we should calculate the Euclidean distance of k number of neighbors. In the step 3, take the k nearest neighbors as per the calculated Euclidean distance. Step 4, among these k neighbors, count the number of data points in each category. Step 5, assign the new data points to that category for which the number of neighbor is maximum. Step 6, our model is ready. Suppose we have a new data point and we need to put it in the required category. Consider the image. See this image. X1, X2 is there, category A, category B, and the new data point. Firstly, we will choose the number of neighbors. So we will just choose k equal to 5. Next, we will calculate the Euclidean distance between the data points. The Euclidean distance is the distance between the 2 points, which we have already studied in the geometry. It can be calculated as x1, y1, x2, y2 are the 2 points A and B. So, Euclidean distance between A1 and B is root over x2 minus x1 whole square plus y2 minus y1 whole square. By calculating the Euclidean distance, we got the nearest neighbors as 3 nearest neighbors in category A and 2 nearest neighbors in category B. So, the new data point belongs to the category A because majority is in category A. As we can see, the three nearest neighbors are from category A, hence this new data point must belong to category A. How to select the k value in the KNN algorithm? There is no particular way to determine the best value for k, so we need to try some values to find the best out of them. The most preferred value for k is 5. A very low value for k, such as k equal to 1 or k equal to 2, can be noisy and lead to the effects of outliers in the model. Large values of k are good, but it may find some difficulties. Advantages of KNN algorithm. It is simple to implement. It is robust to the noisy training data. It can be more effective if the training data is large. Disadvantages of KNN algorithm. always needs to determine the value of k, which may be complex sometime. The computation cost is high because of calculating the distance between the data points for all the training samples. See the problem. Here they have given height in centimeters and weight in kgs, and the class they have mentioned as underweight normal. And for the new data point 17057, we should find which class it belongs to. For that, KNN algorithm is very useful. Calculate distance using the formula d equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. After finding the Euclidean distance, you rank the each data point which is have less distance from the new data point, that you should rank as 1 and 2 and so on. According to the value of k, we will check now. If k equal to 1, then it is normal. If k equal to 2, then it is normal only. If k equal to 3, see 1, 2, 3 all are belongs to normal, so it is normal only. If k equal to 4, you check. If k equal to 4, 3 normal, 1 underweight. Majority is normal, so it is normal. If k equal to 5, we will check 1, 2, 3, 4, 5. 3 belongs to normal, 2 belongs to underweight. Majority is normal, so if k equal to 5, it is normal. Now we will see the code explanation in Python in the Google Collaboratory. First, you import the necessary libraries from sklearn.model underscore selection, import train underscore test underscore split. From sklearn.neighbors, import KNearestNeighbors classifier. From sklearn.metrics, import accuracy underscore score, comma, classification underscore report. From sklearn, import the data sets. We are importing, you load a sample data set, you can replace it by any other data set by bringing it into the collab. For demonstration purposes, I am showing only the breast cancer data set from skikit-learn, which is inbuilt. You should replace this with your own data set pa. Hospital underscore data equal to data sets dot load underscore breast underscore cancer of x equal to hospital underscore data dot data, where y is the target variable, hospital underscore data dot target. After that, you should split the data set into training and testing sets. X underscore train comma x underscore test comma y underscore train comma y underscore test equal to train underscore test underscore split of x comma y comma test underscore size equal to 0.2 comma random underscore state equal to 42. KNN underscore classifier equal to k neighbors classifier of n underscore neighbors equal to 3, means we are taking the k value as 3. Train the classifier on the training data. For that, we are writing knn underscore classifier dot fit of x underscore train comma y underscore train, means we are training the model. After that, we are making predictions on the testing data. Y pred equal to knn underscore classifier dot predict of x underscore test. After that, we are going to evaluate the accuracy and other metrics of the classifier. For that, we are writing accuracy equal to accuracy underscore score of y underscore test comma y underscore pred. After that, we are going to print the accuracy. After that, we are going to print the classification report for the detailed evaluation. For that, we are writing print of classification underscore report of y underscore test comma y underscore pred. After that, you can now use the training model to make predictions on the new data. We are taking one new data point x underscore test of 0, and we are going to predict the class predict underscore class equal to knn underscore classifier dot predict of new underscore data underscore point. After that, we are printing that predicted class. Thank you, friends. Like, share and subscribe for more interesting